All right, guys, so this is section 6.2. So in section 6.2, it's all about properties of kites and trapezoids. So in a kite, we are going to have, and this would be something to put in your notes, draw this kite that we have here. And then in a kite, we're going to have two pairs of congruent, and it says adjacent, which just means next to it, okay? Two pairs of congruent adjacent sides. So AB is congruent to BC, and then CD is congruent to AD, okay? So go ahead and put that in your notes. Make sure you draw that. So we have that. Then we have a property with the diagonals. So the diagonals of the kite are going to um, intersect and form a right angle. So the diagonals are perpendicular. So right here, we're going to have a right angle, but we're going to have a right angle in each one. And if you kind of look at it, we have 1, 2, 3, 4 right triangles. So each one of those triangles is going to be a right triangle because where the diagonals intersect, they form a right angle. So just be aware of that, guys. Just be aware of that. So lastly, the last thing that we have is that the one bisects, the longer diagonal bisects the other one, meaning that AX is congruent to XC, okay? So it'd be a good idea to have this picture in your notes with everything marked down just like it's shown on the screen with the right angles, the congruent sides, okay, everything, just so you have an idea of the properties of the kite. So let's do some examples. All right, so you're going to see problems like this where they give you an angle and you have to solve for other angles. So if we're looking at this, they give us that this angle is 21 degrees. We have to solve for 1 and 2. Well, 1, you should know right off the bat, is a right angle. So the measure of angle 1 is going to be 90 degrees because it's the angle formed from the intersecting diagonals, and the diagonals are perpendicular, so they're going to form a right angle. Now, the next part is to solve for angle 2. Well, in that triangle, I know that I have that right angle, that's 90, but right now I don't know any of the other ones. They didn't give me any more information. So you're thinking, like, how do I solve this one? Well, if we're looking at this, okay, this blue triangle, oops, hold on, hold on. So let's erase that. So this blue triangle right here, okay, so that triangle, like we said before, is a right triangle, okay? And we also have this triangle, which that's going to be pink, okay, on top, okay? That's a right triangle as well. Now, those two triangles are going to be related in some way. They both have right angles here, and since they're both right triangles, this is where chapter 4 is going to come into play, okay? So, they have these sides that are congruent. That's the hypotenuse in both triangles. And they also share this side. That would be a leg in both triangles. So these triangles are congruent by hypotenuse, leg. So since they're congruent by hypotenuse, leg, we know that all parts in those triangles will be congruent by CP, which is corresponding parts of congruent triangles are congruent. So saying all that is just a roundabout way of saying that if this angle is 21, then I also know that this angle right here is 21. So if I draw that triangle a little bit bigger, I have that this is angle 2, this is a right angle. I'm going to know that this angle is 21, all right, because it's congruent to this triangle right here on the top. So then all I have to do to solve for the measure of angle 2 is just do 90 plus 21, okay? And when I do that, that's going to give me 111. All right, and then I just do 180 minus 111, which that would be 69. So 69 degrees is going to be the measure of angle 2 down there. So that is how you're going to solve those problems, guys. let's move on to trapezoids. All right, so in a trapezoid, so I have a trapezoid here. We have a couple different properties, okay? So, in a trapezoid, we have, this is kind of the naming of the sides. We have the two bases, which are the two parallel sides, and then we also have the two legs, which are the non-parallel sides. So just any old trapezoid, bases are parallel. We don't have anything that's congruent, though, with the sides. We have congruent, or not congruent angles, but we're going to have supplementary angles. So just be aware of that, guys, because a lot of people kind of think like when we see parallel lines, we should know that angles are going to have a relationship, not the sides. So for this, this is going back to parallel lines cut by a transversal. So we have our parallel lines. We're going to know that this angle and this angle would be same side interior angles. And same side interior angles are supplementary, meaning if this angle was 100 degrees, well, we do 180 minus 100 and get 80 for the measure of that angle. If this angle is 120 degrees, we would subtract from 180 and get 60 for the measure of that angle. Okay, so that's how we'd solve for those. And this is just any old trapezoid. We just have relationship on the transversals. Nothing like there's no 60 and 80 don't have a relationship, okay, just yet. Now, so this was for any old trapezoid, just any trapezoid. And why I'm saying that over and over and over again is because we have this isosceles trapezoid, okay? Which isosceles, hopefully you learned from was chapter 4, that isosceles means two sides and two angles are going to be congruent, okay? So for this, we're going to have two sides, the two legs are going to be congruent, okay? And then each pair of base angles is also congruent, meaning that angle A is congruent to angle D, angle B is congruent to angle C. Okay, so A is congruent to D, B is congruent to C. And so if you guys look in the picture over here, we have 120, 120, 60, and 60, and it also holds true the property where the same side interior angles are supplementary because we have 120 and we have 60, so 120 plus 60 would be 180. All right, guys, so just be aware of that. Isosceles trapezoid, two sides are congruent, and then also two pairs of angles are congruent as well. And then lastly, I want to talk about the trapezoid mid-segment theorem. Okay, the trapezoid mid-segment theorem. And that theorem just states, so we're going to have a mid-segment, and hopefully you remember mid-segments from chapter 5, so I hope you've seen that, like, everything that we've done so far is kind of coming up again. A mid-segment is formed from the two midpoints, so x and y are the midpoints, and it creates two congruent segments. And this mid-segment theorem is going to work for any trapezoid. It doesn't have to be an isosceles trapezoid. It can be any trapezoid out there. So we're going to have the two congruent segments there. So you might get a question like that. But the more important thing with this trapezoid mid-segment theorem is that if we add up the bases, so if we add AD and BC and divide it by 2, that is going to give us the length of the mid-segment. So you see in this problem over here, we have the one base is 4.2, the other base is 10. So we're going to do 4.2 plus 10, and if we're multiplying by 1/2, it's the same thing as dividing by 2, so I'm just going to divide it by 2, okay? Same thing, it's just that's easier for me to solve than multiplying by 1/2. So when we do 4.2 plus 10 divided by 2, we're going to get 14.2 divided by 2, which that would give us 7.1, and that is the length of the mid-segment here. So that's how we found it, okay? We just added up the bases and divided them by 2, okay? Divided them by 2. So let me pause. So you guys could also have a problem where we're using expressions, and for this problem right here, we know that XY is the mid-segment, UV and TW are the bases. So TW is a base, UV is a base. So we're going to add up those bases. So we're going to do 3x minus 1 plus 8x, okay? Divide that by 2, and that is going to equal the length of the mid-segment, which is 3x plus 7. So we use the definition, okay, saying we add the bases, divide them by 2. That is going to equal the mid-segment, okay, since we're using expressions here. So we're going to do 3x plus 8x. That would give us 11x minus 1 divided by 2 equals 3x plus 7. From here, what I'm going to do to get rid of that 2, because 11 divided by 2, that's going to give me a decimal. I don't want to work with that. I'm going to multiply this side by 2. Okay, the 2's will cancel. I'm going to also multiply this side by 2. Okay, and when to do that, I'm going to distribute the 2 through. So I'm going to have 11x minus 1 on this side. That is going to equal 6x plus 14 on this side. Then you guys are good from here. Normally is we're just going to add the 1, subtract the 6. Okay, so we're going to get 5x equals 15. So x would equal 3. So that's how you solve a problem like that. But that is it, guys. So good luck with everything. If you have questions, let me know. Otherwise, have a good day.